We've spent quite a long time looking at differentiation. How do we undo this procedure? That is, given a function, how do we find its antiderivative? That's the topic for this video. How do we undo differentiation? For simple functions, it's relatively easy, but for more complicated functions, we need to establish a general procedure for doing this. If I take the function f of x equals sine x, then I know that antiderivative of sine x is minus cos x. Is that all there is to it? Well, not quite. Let's define a function as an antiderivative. A function, capital F of x, is an antiderivative of f of x, provided the derivative of capital F is equal to little f. So, an example of this, we know that velocity is given by the derivative with respect to time of distance. So that means that the position function is an antiderivative of velocity. Let's go back to our initial example with sine and cosine. We know that an antiderivative of sine is minus cosine x, which means that when I differentiate minus cosine, I get sine x. But what if I add the number 3? This is also an antiderivative of minus cosine of x. So is that all of them? Well, actually no. The most general antiderivative is equal to minus cosine of x plus any old constant. And in fact, we can think of this as an arbitrary constant. So in fact, the antiderivative of a function isn't itself just a simple function, it's a family of functions, an infinite family of functions. Let's try an example. Let's try and find the general antiderivative of x times the square root of x, or x to the 3/2. Given that we know how to differentiate powers of functions, we can see that the antiderivative must be something like x to the 5/2, since when I differentiate x to the 5/2, that leaves me with x to the 3/2. If I just check what the derivative of x to the 5/2 is, then this implies that x to the 3/2 can be written as 2/5 times the derivative of x to the 5/2. So my general antiderivative then is 2/5 x to the 5/2 plus a constant. Provided I can guess what form the antiderivative is going to take, it's relatively easy to find the antiderivative. But in fact, it's not always quite as obvious as it seems. So let's say we're given the function minus 1 over x minus 1 squared and ask what is the antiderivative of this. It might be tempting to just jump to the conclusion and say, well, if I differentiate 1 over x minus 1, that's going to give me minus 1 over x minus 1 squared. So that looks like it's sensible. A sensible starting place anyway. What about if I note the following? What's this equal to? Well, if I use the product rule, then the derivative of x is 1 over x minus 1, and then the denominator gives me an x minus 1 squared. Now, if I combine those together, I'm left with x minus 1 minus x over x minus 1 squared, which we see simplifies to minus 1 over x minus 1. So which is the antiderivative of minus 1 over x minus 1 squared? Well, it turns out they both are, and even though they look functionally different, they actually only differ by a constant. So we can check this. The initial guess was 1 over x minus 1. Let's add a constant to that and then factor it. Now, if c equals 1, we get x over x minus 1. So those two functions, even though they looked a bit different, were both actually antiderivatives of the initial function.